Looking at surface area, volume, and linear relationships and similar figures. We've been talking in the past how if I have two figures and I have two similar objects, let's say I have an object that looks like, I don't know, like this object and this object. They are similar. Okay? If I would take any length measurement, they would be in a ratio A to B. This is lengths. The area would be in a ratio A squared to B squared. That would be area. And the volume is A cubed to B cubed. And we have to always kind of go back to A to B if we want the surface area. Or if we're given the area and we want volume, go to A to B, then get to the volume. So we're always going back and forth between them. In this particular problem, we have 24 kilograms and 81 kilograms, which are both, we can treat those as volumes. And so I know that 24 to 81 is the proportion of volume. If I simplify that fraction, I can divide both by 3, and that gets me 8 over 27. And I know this is A cubed and B cubed. So if I cube root this, cube root 8, and if I show you how to do that in a calculator, if you go math, let's toggle down to number 4, that's 8. Oh, hold on, what did I do there? Try that again. 8, toggle down, number 4, of 8. That will give me 2. The other one I know I could do the same thing, but it's going to be 3. This is no longer volume. This is now linear A to B. Now I want to take that and put it to surface area is what I'm looking for. So if I want surface area, that's A squared to B squared. So I'm going to change that to 2 squared to 3 squared. Now this value here is area proportion. This is linear proportion. This here is volume proportion. I know from the problem the larger object is 540, so that's got to be on the bottom. And the area I'm looking for is there. And so I do some cross multiplying. I go 4 times 540 equals 9a. 4 times 540?
4 times 540. That is 2,160.
2160 equals 9a. Divide that by 9.
240.
Exactly?
Yes.
Okay. And the units for that is going to be centimeters squared. It's an area. Okay, so I took volume proportion, made it to a length proportion, then changed it to an area proportion. And you have to be able to work all with those. Go back and forth depending upon what you're looking for and what you have. The second part of the question says to find it in terms of millimeters squared, I believe. To convert this area to millimeters squared. So if I'm going to take 240 centimeters squared, 240 centimeters squared, I want to change it to millimeters squared. Well, again, I'm going to use this idea of proportions. I know that 1 centimeter is 10 millimeters. Those are linear. If I want a squared, I take it and I square them both. And now I can find, this is my x I'm looking for, and this is 240 centimeters squared. So I know 1 squared is 1, 10 squared is 100, equals 240 centimeters squared over x. I cross multiply, and x will be 24000 millimeters squared. If I convert that to scientific notation, I'm going to go back 1, 2, 3, 4 places. It's 2.4 times 10 to the 4. 3 significant figures, though. I have to write my 0 in there to keep 3 significant figures. And that is my millimeters squared.